welcome back to Curly Boy Theater for our last talk of the day. Because this is our last talk of the day, please remember that the conference closing will be in this room where we are right now. After this talk, there'll be a very short break in between, so stick around after the end of the talk to hear from our lovely conference organizers. Okay, so we have for us all today Sebastian Witkowski to talk about Python versions and dependencies made easy, if I get the title correct. Sebastian is a Python consultant and trainer based in Poland. He started his journey with programming as a software developer at CERN, where he fell in love with Python and teaching. Now he is helping companies untangle their complicated architecture and build all sorts of interesting Python projects. So if there is time at the end, Sebastian will be taking questions. So please put your questions in the question tab in Venulus. You should all know where it is by now, hopefully. If not, ask away, and I'll ask them at Sebastian at the end. Over to you, Sebastian.
Cool. Thank you very much. Hi, everyone. So, my name is Sebastian Witkowski, and I'm a Python consultant, freelancer, and trainer. So, as part of my job, I join different teams and work on different projects. And as I work on those different projects, I notice that they often suffer from one of two problems. They are either over-engineered or stuck in the 90s. The over-engineered ones involve jumping on every shiny new tool that you find on the first page of Hacker News. And then everyone gets excited because, well, it's fun to work with something brand new. What is not fun is when your tool gets deprecated. Maybe its creator got bored and they stopped working on it. So now you have to either fork it and keep it up to date yourself, or you have to replace it. On the other hand, we have projects that are still stuck in the 90s. Some people think that because it was fun to manage everything using bash scripts back then, it's still fine to keep using bash scripts today. I mean, it's fun if you're a hardcore Linux user and you love writing bash scripts, but to be honest, when was the last time you wrote one? Okay, writing them from scratch is not that bad. Maintaining a bash script that someone else wrote is much worse. And I don't mean that bash scripts are bad, they are actually pretty great for simple things, but you should use tools more suitable for the task at hand. So neither of these situations is good. You should update your tools, but at the same time, you should choose those tools that you know that they are proven and they will be supported for the next few years. So that's why I've decided to make this presentation. I want to show you some useful Python tools that will make your life easier. Tools that I recommend to my colleagues and to my clients. We'll talk about things that a lot of beginner programmers struggle with at some point. So first I will show you how to install different Python versions and how to manage them on your computer using a tool called PyEnv. Next I will talk about Python dependencies. I will explain you what are virtual environments, how they work, and why you need them if you work with multiple Python projects. I will also compare the built-in venv module with some external tools like Virtual Nwrapper. And finally, we will talk about a tool called pipx. This is a great tool if you want to install some Python package globally, but you still want to isolate it from other packages on your computer. And before we move on, I really want to highlight one thing. Those are all just tools, and there are a lot of other tools that do the same thing. If you use something else, that's great. My goal here is not to convince you that those tools are the best. No. I just want to show you how to solve some basic problems when you configure your development environment. If, for example, you are using Conda and you are happy with it, then the first 2 bullet points from this list are already solved for you, and that's perfectly fine. But if you don't know what to use, let me show you some recommendations. So first, let's talk about installing Python on your computer. Depending on your operating system, your computer might already come with some version of Python installed. If you're using Mac OS, it comes with Python 2.7. If you're using Linux, then the Python version depends on which distribution you are using. And in Windows 10, you don't have any Python installed. Let's say that your operating system comes with some Python version. This Python version that is already installed on your computer is often called System Python. And no matter what system version of Python you have, I strongly suggest that you don't use it. In many cases, as we saw with Mac OS, it's terribly outdated. I mean, Python 2.7 is officially not supported by the core developers, so hopefully you are not using it since a long time. You might be tempted to update this system Python to Python 3, but you probably have some programs on your computer that require Python 2.7. You would be surprised how many programs on or even parts of the operating system still requires Python 2.7, at least in macOS. So if you update system Python, those programs will stop working. So if you change the Python version that comes pre-installed on your computer, you risk that your computer will stop working at all. And that is not fun. I have done this in the past when I didn't know much about programming and operating systems, and I had to reinstall the whole operating system. So my advice here is to leave the system Python alone and pretend that it doesn't exist. So no matter what operating system you have, you will need to install Python. And there are many different ways how you can do this. You can go to the python.org website and download the installer for your operating system. You can use a package manager like Homebrew on Mac or apt-get on Linux. And you can even compile Python from the source files. However, my favorite way of installing Python that I have been using since a few years is to use a tool called PyEnv. PyEnv is a tool for managing Python versions. You can use it to easily install a Python version on your computer, but also to quickly switch between those versions that you have already installed. It might not be a big deal if you only use one Python version at the time, but if you're working with multiple Python projects that require different Python versions, this tool is extremely useful. For example, when I do some courses or tutorials on Python, I try to use the latest version of Python. But when I work with my clients, they usually don't use the latest version of Python. I've been using PyEnv for years and it works very well. If you have worked with different programming languages, like you might recognize similar tools. For example, there is RBEnv for Ruby, NodeEnv for Node.js, or GoEnv for Go. While PyEnv will work fine on macOS and Linux, if you're using Windows, check out the PyEnv Win. This is a port of PyEnv to Windows, and it might not have all the features that the standard PyEnv has, but it has all the essential ones that I will talk about. But then again, if you are on Windows and you are a happy Conda user, then there is actually no point in switching to use PyEnv. One of the things that Conda can do is to create virtual environments using a specific Python version, which covers 2 out of 3 bullet points in the stock. You can install PyEnv with Homebrew, you can clone it with Git and manually adjust a few settings, or you can use the tool called PyEnv Installer. And while this last option requires you to download a bash script from the internet and run it in a terminal, which is a big security no-no, it's actually very convenient. It will not only install PyEnv, but it will also install some additional plugins like PyEnv Doctor that you can use to verify that your PyEnv installation is working fine. So once you have PyEnv installed, you can use it to install new Python version. To see the list of all the available Python versions, you can run pyenv install -- list. And you will see a huge list of available Python installations. At the top, we have the standard C Python versions, but apart from that, we have ActivePython, Anaconda, Miniconda, PyPy, and so on. So all those different versions of Python can be installed with PyEnv. If you ever wanted to try PyPy, now you can very easily do this. Once you select a version from this list, type pyenv install and the version number and go make yourself a coffee. I mean it, the installation usually takes a few minutes. There are some additional libraries like OpenSSL that you can pre-install to make this process faster. If you don't have those libraries installed, then each time you try to download a new Python version, PyEnv will try to download it and temporarily use it. So I suggest you take a look at the GitHub page for the list of the required dependencies. Okay, so once this is done, you can run pyenv versions to see if this new version is on this list. If you can see it there, then it means that you are all set. So now we have to tell PyEnv to use that version. And for that, we have to choose one of 3 different levels at which we can change the Python version. We have global, local, or shell. So what does it mean? Well, 9 out of 10 times, you probably want to change the global Python version. And to do that, you just run pyenv global 3.9.0, and that changes the global Python version on your computer. Then we have pyenv local. So imagine that most of the time you are working with Python 3.9, but you have this one project on your computer that requires Python 3.7, and for some strange reason, it won't work with any other Python version. So instead of changing the global Python version to 3.7 when you work on this project and then changing it back to 3.9 when you stop working on this project, you can set a local Python version. And that's where the pyenv local command comes in. You can run pyenv local 3.7 or 3.9, and it will set that version for the current folder and all its subfolders. So whenever you go inside this folder, Python version will automatically change. And when you go outside of this folder, it will change back to the global one. That's very handy when you work with multiple projects that use different Python versions. So instead of changing the global Python version back and forth, you just have to run pyenv local in one folder, pyenv local in another folder, of course, different versions here. And then pyenv will automatically change the Python version when you go inside each of those folders. And then finally, we have pyenv shell. And this changes the Python version used in your current shell session. You might want to use it, for example, when you want to temporarily change Python version that you're using. Let's say you want to run some code under Python 2, so you just run pyenv shell 2.7.18 and you can use Python 2. But once you open a new session in your terminal, you'll go back to using the previous version of Python. So that's how you can easily manage Python versions on your computer. Let's talk about dependencies. Let's start with pip. Pip is a package manager for Python. Whenever you want to install a new package, all you need to do is to run pip install, add the name of the package, and it's working. However, pip has one big problem. Whenever you ask it to install a specific version of a package, it will uninstall the previous versions from your computer and install the one that you asked for. Let me show you an example of what I mean. Imagine you are a web developer and you want to build a Django website. You start by installing the latest version of Django with pip install Django, and that installs some version of Django 3. Everything works great, you build an awesome website. And the website is so awesome that your client or your colleague or family member asks you, hey, you're making awesome Django websites, so can you give me a hand and fix my Django website? As it often happens with clients, they are not using Django 3, they are still using, let's say, Django 2.2. So you install that specific version by typing pip install Django == 2.2. And pip does what you ask for, and after a few seconds, you start working on this website for your client. So far, so good. But later that day, you discover that your personal website, so this one built with Django 3, has a bug. So you go there, you quickly fix the bug, but when you want to test it and make sure that it's working fine, you get an error message saying Django 3 is not installed. Like, what? I mean, we installed it yesterday. What happened with it? Well, when we told pip to install Django 2.2, pip first checked that if we already have Django installed. And we did, it's just it wasn't Django 2.2. So pip uninstalled that version and installed the correct one. So we just ran into a problem with dependencies management. We have this problem because pip installs Python packages inside the side packages folder and puts each package into a separate folder named after that package. So Django 3 is placed inside side packages /Django, But when we want to install Django too, it will also be placed inside side packages/Django. So pip has to first remove what's inside this Django folder and then install a different version. If you only work with one Python project all the time, then you're probably not affected by this problem. But sooner or later, you will need to install different versions of the same package, and you are going to run into issues with pip uninstalling some dependencies of some other packages. The problem with pip is that it installs all the packages in the same folder. So how about we tell pip to temporarily install packages into a separate folder, and then we tell our Python interpreter to use packages from that folder? Well, that's exactly what virtual environment does. A virtual environment is a folder that contains a Python installation and any additional packages that you install. When you activate a virtual environment, two things happen. So first you tell pip, hey, I want you to install any new Python package in that folder. And then you tell Python interpreter, hey, I want you to use Python and Python packages from that folder. Now, if we try to install some Python packages, pip won't uninstall the previous versions from the global side packages because it's no longer using the global side packages. It's using side packages from this specific virtual environment. So how does it look in practice? Well, first we need to create a virtual environment. Python has a built-in module called venv to manage virtual environments, so we don't even have to install anything. We create a new virtual environment with command python -m venv and then the name of the virtual environment. So in my case, I'm creating a folder called .venv inside the current directory. .venv or venv are both a common name used for folders with virtual environments. So it makes it obvious that whenever you go into some Python project and you see this folder, inside there are things related to virtual environment. But it also has another benefit. Some code editors like PyCharm or VS Code will recognize this folder as a virtual environment, and they will automatically start using it in your project. So we have created a virtual environment, and now we have to activate it. So inside our venv folder, we have a bin directory, and there we have the activate script. Since this is a bash script, we have to run it with source command. And of course, if you're using a different shell, there are different files that you can use. For Windows users, there is activate bat and so on. Once you activate it, you should see a difference in your terminal's prompt. It should now display the name of the current virtual environment. So if you see something like this venv in parentheses, that's great because it means that a given virtual environment is now active. And now we do everything that we would normally do when building a Python project. If we install a package with pip, it will be installed inside this virtual environment. And if we run a Python script, it will have access to Python packages from this virtual environment. And if you want to stop using the virtual environment, you have to run the deactivate command. When you call it, it will revert all the changes that the activate did. So you will go back to using the global Python version and back to global pip packages. So a typical workflow using virtual environments involves creating one virtual environment for each of your projects. So if you're working with two Django projects, you first create one virtual environment, you activate it, you work on it, and then if you want to switch to another project, you create another virtual environment, you activate it, and you work on that project. venv module is perfectly fine. Oops, I pressed the button. venv module is perfectly fine for managing virtual environments. But I want to show you another tool that I have been using for a long time. It's called Virtual Env Wrapper, and it comes with a lot of cool features that makes working with virtual environments easier. You can install it with pip, and of course it works on Linux and Mac, and for Windows users you have to use something else. There is a tool called Virtual Env Wrapper Win that contains almost the same features as Virtual Env Wrapper. But then again, if you are a happy Conda user, you can stick to using Conda for managing virtual environments. Virtual Enwrapper stores all the virtual environments inside the .virtualenvs folder inside your home directory. And it provides you with some additional useful commands for managing virtual environments. So you can create a new virtual environment by just typing mk virtualenv and the name of the environment, let's say Django 2 app. But unlike the venv module, it's not creating the virtual environment in the current folder, it's creating it inside this venvs in your home folder. Now, if you want to activate your virtual environment, you just have to call work on Django 2 app, let's say, and then Virtual Enwrapper will figure out where is the activation script for that virtual environment. You don't have to type the whole path to the activate script and figure out in which folder it's located. And if you forget the name of the virtual environment, you can just call ls virtualenv, and this will list you all the virtual environments that you have. Again, with venv, it's impossible to get this list because venv doesn't keep a track of what virtual environments you have, and Virtual Enwrapper stores everything in one folder, so it's very easy to get that list. And finally, to remove a virtual environment, you just have to run rm virtualenv and the name of the environment. So you're probably wondering which one is better, venv or Virtual Enwrapper. Well, both tools are great, and it really boils down to how you like to use your virtual environment. I use Virtual Enwrapper mostly because I don't want to type this whole source venv/bin/activate, where of course half of the time I'm in like some subfolder of my project and I get the error that venv folder doesn't exist, so I have to figure out where this activation script is located. No, I just like to say work on Django 2 app and be done with it. And another thing is that I also create some virtual environments that are not connected to a specific project. For example, I have this one virtual environment with a bunch of data science libraries, and I use it each time I want to run Jupyter Notebook with Pandas and NumPy. And one more thing, Virtual Enwrapper has, for example, a function to create temporary virtual environments. So it will make a virtual environment where you can install some pip package and test them. And when you deactivate it, it disappears. So it's really nice for testing some pip packages. But venv module also has benefits. If you store virtual environments in the same folder as the rest of your project, your code editor will pick it up and start using automatically. And also when you delete this project, you also delete the virtual environment with it, so you don't have to manually clean it up later. And of course, venv is a built-in module, so you don't have to install anything. All right, so we have covered how to manage Python packages inside your projects. What about global Python packages on your computer? Some tools are much more convenient to use when you install them globally instead of installing them in a specific virtual environment. For example, the Code Formatter Black, the Linter Flake 8, or the Virtual Enwrapper that we just discussed. You want to use those tools across all your projects or even before you create a project. For example, with Virtual Enwrapper, we would first create a virtual environment before we start working on a project inside that environment. But then again, if two different tools require two different versions of the same dependency, we have a problem. You install one tool and everything is fine. You install the second tool, it changes some versions of this first, it changes some dependencies of this first tool, and then the first tool stops working. We could install each of those tools inside a separate virtual environment, but this is a lot of hassle to use it like that. So each time you would have to activate a virtual environment, run a command, and then deactivate it. I mean, you can do this, but it's a lot of typing and generally it's a waste of time. We can easily solve this problem with a tool called pipx. Pipx installs Python packages inside separate environments, but at the same time, those packages act like if they were installed globally. So you don't have to activate any virtual environment to use them. How does it look in practice? Let's say you want to install Black to format some Python code. We run pipx install black, and after a few seconds, we get a success message saying that black has been installed. And now we have those three commands available: black, black primer, and black t. And now we can use black as if it was installed with pip. It doesn't matter if we are inside a virtual environment or not, we'll always use this global black package. We don't have to activate anything, we just run the same commands as we would run if we weren't using pipx. And if we want to install a different version of black inside a virtual environment, we can still do this. This black from inside the virtual environment will always take precedence over the global black. So as long as this virtual environment is active, you will be using black from this virtual environment. What else we can do with pipx? We can list all install packages to see what commands they offer. We can uninstall a package, and this will also clean up its virtual environment. We can upgrade all the global packages with one command called pipx upgrade all. And then we have one very useful command called pipx inject. It will install a pip package inside the virtual environment of another package. You might use it, for example, to install some PyTest plugins. So let's say we want to add a plugin called PyTest Cov to display the test coverage of our code. We can't just run pipx install PyTest Cov, because it will install PyTest Cov inside its own virtual environment, and PyTest won't see this package. Again, because pipx installs every package inside the separate virtual environment. So we have to call pipx inject pytest, PyTest Cov, and this will install PyTest Cov inside the virtual environment of PyTest. And that brings us to the end of my presentation. So let's quickly summarize what we saw. First, use pyenv to install new Python versions. Once you set it up, it's really easy to install new Python versions and to switch between them. Then use virtual environments when you work on different projects and you want to isolate their dependencies. Always make sure to create a separate virtual environment for each of your projects. Python comes with a built-in module called venv that is perfectly fine to use it, but if you prefer a tool with some additional functionality, virtual env wrapper is also a really great choice. And finally, if you want to install some tools globally, you can use pip outside of a virtual environment, but you risk that if there is some version conflict, they won't work together. So a much better tool to use is called pipx, and this will install each global package into a separate virtual environment. But for you, there won't be any difference in how you use them. Thank you very much for listening, and I think we still have some time for some questions.
Thank you, Sebastian. We probably have time for one question, and we have two questions. So I'm going to use my powers to pick. I lost it. Okay, so someone asks, I'd love to know which method is best used in production. Is there a set of best practices to follow?
So for production, I use yet another tool that I didn't have time to put in this talk. So I use a tool called, what was the name? pip_tools. So it has a command called pip_compile, and you can provide a list of dependencies. Like you just specify, I want Django, I want PyTest, I want something else. You can have multiple requirements files. It will take those requirement files and resolve all the dependencies and give you a list of all the dependencies pinned. So third-party packages, dependencies that you use, dependencies that your packages use, and so on. You take this and you put it into a Docker image, you put it on the VM or whatever you want to use it. So that's what I would use in production.
Yeah, pip_compile is great. I use that too. All right, there's a lot of more questions have just come in while we've been saying that, but we are out of time. So, Sebastian, would you like to head over to the text chat channel for a few minutes?
Yeah, sure
to
thing.
answer some more? All right,
I'll be
so
on.
everyone, do jump into the Curly Boy Theater text chat channel, and I will paste the questions over there. But leave, like, when you jump into the text chat, the stream for Curly Boy Theater will keep playing up in the top corner. Leave that playing because the conference closing is coming up in 15 minutes, okay? And we don't want anyone to miss that because, you know, PyCon AU is special, and that's all of it, including the closing. All right. So thank you once again, Sebastian.
Thank you so much for
I
having
think
me.
that was really helpful. The chat was on fire. So thank
Thanks.
you.
Bye bye.